Hi everybody, this is Professor Millman and I'll be going over a review sheet for Module 2 exam. As before, I'm recommending that you try these questions on your own before you watch the solution. Alright, let's begin. Question number 1. The table below lists the population and land area for 3 countries, and we are asked to list the countries in increasing from smallest to largest order of population density. If you recall from the class, lesson 2.1, population density is defined as people on top of the area. So you're dividing people by the area to get the density. Now, for the purposes of the review, here the population is written in thousands. We don't want to ignore that information, so we're going to go ahead and add 3 zeros to those whole numbers. And when it comes to Vatican City, 1,000 means multiplied by 1,000, or per each 1,000. So for the last one, the decimal point will move 3 places to the right, and then we're going to take the populations and we're going to divide them by the areas. Here are the numbers that you see. All of these are people per square mile. So if we rank them, the lowest one would be Fiji, followed by Cuba, followed by Vatican City, which will give us the answer choice B. Note the Vatican City is small, only 832 people lived there in 2014, but the area is really tiny. So when you're dividing it, it does make sense and we get such a crowded density. All right, let's go to question number 2. Tuition at university and colleges in New Jersey increased by 2.3% in 2014-15 academic year. Which type of the college will have the greatest absolute increase in the tuition? So it's the difference between an absolute and a relative change. So 2.3% represent the relative increase. All right. And the absolute change is which one will have the largest dollar increase. You can go ahead and calculate the absolute increase by finding 2.3% of each of the following numbers, because it's talking about like a median tuition. But you can also think logically that 2.3% of the largest tuition value will produce the largest absolute change. So therefore, the private universities are the one will undergo the largest absolute dollar increase. Question number 3. The U.S. student loan debt grew from $966 billion to $1.29 trillion. Calculate the relative change. So this is just a review of how it goes, how you calculate the relative change. So one way to do it is to find the difference. I like to do it this way. Now minus the past divided by the past amount, where it is relative. Past is a number in the past, and then now it's kind of like the future value, like where it is the year that is further away, basically. So when you look at 2012 and 2015, now will be like 2015, the more recent years minus the prior year that's given in a question. All right, so I like to write it this way. And then we go ahead and we calculate this, and we got to be very mindful of what form our numbers are. So if you like, you can go ahead and write that in the expanded form. So 1.29 trillion can be written like this. The trillion means 12 significant figures after the full trillion. So 3, 6, 9, 12. All right, so it's basically the ones that after the decimal point followed by 10 more zeros. Altogether gives us 12. So that's a trillion. And then you will divide it by 966. Oh, well, dividing it. You're subtracting then the past amount, which is 966 billion. Billion is 9 significant figures. It doesn't even fit right here on the screen. You know what? I'm going to go ahead and paste it down a little bit because I want to then print out the solutions. So I'm going to move this way. Okay. And let me write it. So 3, 6, 9. And notice how they share. Oh, they can both be expressed in terms of the billions. So it's actually much better to actually not use all of those zeros in the standard form because it's easy to get lost with those, and instead rewrite 1.29 trillion as 1,290 billion and deal it like that. Either way, you want to be careful in what units are you use, in what form you're using your numbers. So it's either in a standard expanded form, or in this case, you can express them all in billions. Okay, so you do the subtraction first, then you divide, and then you'll convert that into a percent. So once you subtract, you get 324 billion divided by 966 billion, and you convert that ratio in percent. So 324 divided by 966 multiplied by 100 gives us 33.5% increase, which is the choice D. All right, so question number 4 has to do with the graph. So it's illustrated level education for the US, different degrees, and we have 3 statements which we want to say whether they're true or false. Okay, so statement number 1: in 2008, the number of people with some college but no degree was approximately 2 times that of those who had received a graduate or professional degree. So some college degree is 22%, and we are comparing this with the graduate or professional degree, which is right here. Okay, and it is approximately 2 times. Well, if we do the ratio of 22.2 divided by 10.5, you can see that it is about twice as many. So that statement is true. So let's put a check mark to it. Statement number 2: the number of people who had received an associate degree was approximately 14.4 million people in 2008. So let's break this down. So the number of the percentage of people who received associate degree is 8.4%, and that is out of 159,515,000 people of that age in the year 2008. So that means we need to do the calculation to check whether that statement true or false. So we're going to find 8.4% of that amount. All right, so that means you're going to times this by 0.084. Okay, be careful when you're converting, and you get 13,399,260, which is about 13.4 million people, while in a statement there it says 14.4. So that statement is false. And finally, people who had received a bachelor's degree constitute about 1/5 of the US population. So bachelor's degree is 19%. All right, so now how does 19% compare to 1/5? It's a good question. You want to either convert 19% into a fraction, but I think it would be better to convert a fraction into percent. So 1/5 is 0.2, which is 20%. Is 19 close to 20%? Yes, because it says about. Okay, it doesn't say exactly 1/5. So 19 is pretty close to 20. So that statement is true, and therefore the answer choice here that is correct would be choice C. Alrighty, let's move on. Question 5. Which of the following statement is true? If 682 is the mode of 15 numbers, there must be more numbers with the value of 682 than any other number in a group of 15. That's a true statement. That's a definition of the mode, the most common number in a data set. Statement number 2, 682 is the median of 15 numbers. If you sort the numbers from smallest to largest, the middle number in the list would be 682. That's a definition of a median. It's a number in the middle. If there are 2 numbers in the middle, if there are even number of numbers, then you will have 2 numbers in the middle and you will average them out, add them up and divide it by 2. So that's also a true statement. And the last statement, the mean of 15 numbers is 682. Half of the number must be more than that. Well, that would be true if it was a median. If the median is 682, you have half of the numbers are more and half of the numbers are less. The mean is not that. Mean is affected by extreme observation. It's not a true center of the data set. So that statement is going to be false. So the correct answer is choice number C. Statement 1 and 2 are true, while statement 3 is false. All right, let's move on. 2015 census estimates by the U.S. government listed the population of Cleveland and the population of Jersey City and their areas. Which of the following is true? So it's asking us to do the population density of each city. So we're going to look at Cleveland. We're going to take their population, which is 397,000 in 2015. And we're going to divide it by the area of Cleveland, which is 82 square miles. And then we're going to take Jersey City, and we're going to take its population, which is 248,000 people, and you'll divide it by 21 square miles. So we're going to divide those two numbers and we're going to compare. Take a moment and compute it. All right, so here you have the numbers, people per square mile. All right, and now we need to say which one is more. Well, it's the Jersey City is more dense. All right, so we're gonna get rid of this, that, and now it's not the same. It's asking it by what ratio, because you see the word times. Times is associated with the ratio. So when you divide this number by that number, divide. All right, and divide the larger by the smaller to see how many times it's bigger, and you'll get the answer of about 2.4, which will give you the choice D. Okay, divide them to double check so you can see it yourself. All right, so the next two questions, we need this table. It gives us the population of 3 states and the United States as a whole. Between the 2000 and 2010 census, it is in millions. Which of the following is true? So it's talking about the relative change. So we want to compute the relative change between each one of them. So what are you going to do? I'm going to demonstrate you just one of them, and the rest I'm just going to write the answers, okay? So to calculate the relative change, we're going to take, let's for example, take North Carolina. You're going to take 9.54, you're going to subtract 8.05, and you're going to divide it by the past amount, okay, in that order. And then you times it by 100, okay? So it's 9.54, take away 8.05, you got 1.49 divided by 8.05 times 100, so it gives you 18.5% increase. So that's a relative change, and that is 18.5%. Okay, by the way, the other way you can get the that number is by dividing those two values, and if you divide them, you're going to get 1.185, and when you subtract 100%, which is a whole, you basically remove 1, then you're going to get the same answer. You see? So, that's an alternative way to do it. But do it the way you're comfortable with, okay? So here it goes. You will see the answers of the other ones in a moment. Okay, here's the relative numbers, okay? Now, if we want, the choices also mention the absolute difference. So let's go ahead and also calculate the absolute difference. The absolute difference, you just simply subtract the two from each other. Okay, so if you subtract them, let's squeeze that somewhere right here. The absolute change, the absolute. So if you subtract, for example, Alaska, it's a relatively small state, so the difference between those two is only 0.08 of a million. Notice the population is measured in millions, which is fine. You could use the numbers like that just to measure the change. It's only 0.08 of a million, and then you subtract the others, okay? All right, so see you got the numbers. Now let's look through each choice. Alaska population increased more than the other states shown. It's actually not true. It's only increased more than Maine. Maine population increased more in relative sense than any other state. No, it's only 4.7%, so it is actually the smallest one of the three. North Carolina population witnessed the greatest absolute change. So North Carolina has the greatest absolute change. That's true, but the least relative change. No, that's false. It's actually had greatest absolute and the relative change of all the states. And the last choice, Alaska population increased faster than Maine. Alaska is faster than Maine. That's a true statement. Okay, so this choice is forcing you to go through every single calculation. So here it goes. Question number 8. According to the census, which state gained the most representation in the House of Representatives in the first decade of the 21st century? Well, this question is a little bit difficult to answer exactly mathematically, because that would require to do a more extensive calculation. But if we had to choose between the states, remember the House representation is based on population size. So if your state increases the most in terms of people and relatively to the entire country, the one that has the highest increase in terms of the rate, relative change, it's more likely to gain representation. So not necessarily that they all going to gain it, but looking at this, the North Carolina has the greatest shot because it has the largest percent increase, relatively taking some representation from other states. So you choose the one with the highest relative percentage. So that's that. And then question number 9, which state get the most representation in the Senate? So for the Senate, it does not really matter. Remember which state has what representation. So all states representation is 2 people, 2 senators per state. No more, no less. Doesn't matter how big the state is. All right. So here it goes. It says which state grew the fastest in terms of the population. So once again, the North Carolina had the largest percent increase, and therefore it grew the fastest. So the fastest is different from the most. The most means the most people it gained. Relative means the highest percentage it increased. In this chart, actually, North Carolina had both the largest percent and the largest absolute change. So out of these 3. It doesn't mean that it's true for compared to other states. Okay. Moving to number 11. In 2015, the population of the U.S. was 320 million. The U.S. House of Representatives has 435 members. Each state is represented in the House proportionally to the population. If the states of Virginia had a population of 8,470,000 people, how many representatives did it have? Remember the lesson representation? There are various ways you could do it, but the way we've seen this in class is we take the population of the United States, we divide it into 435 members to find out what our representation rate is. Okay, so let's divide. All right, so we get 735,000. Oh, keep writing. Wrong thing. 735,632 people per 1 representative, correct? I like to think of this like a cookie cutter. Is that is the slice that we cut from the population to get 1 representative. So the state of Virginia has a population of 8,470,000 people, And if the cookie cutter gives us one representative per each 735,632, we're going to take that divisor and we're going to divide this into the population of Virginia. And that will give us the representation for that state. All right, so let's go ahead and divide. All right, so we're getting 11.5 representatives, but that number is not a whole number, and we cannot have a decimal part of the representative. So now we have a dilemma. Will the answer be 11 or the answer will be 12? The number mathematically, arithmetically rounds up to 12, but conceptually, in order for it to become 12, we need more people, and Virginia has only enough for 11.5, and therefore we got to truncate it and make it 11. So it's not an arithmetic rounding, it is more conceptual rounding. So you always round it down regardless. Even if it's 11.9, you still round out to 11. The actual formula that used in the United States to allocate representation uses slightly different mechanism, but the concept is similar to this. Alrighty, if you want to learn more, you can look at mathematics of voting. There's actually science like that or subject like that within quantitative reasoning. Alrighty, let's move on. Question number 12. The average cost to fly from London to New York City was $11.20 in 2019. It decreased to $9.45 in 2014. And we also have information from LA to Tokyo. Which of the following statement is true? So it's asking us to calculate the absolute and a relative change between the two. All right, so I'm going to do the calculation from New York City to where we're flying, to London. London to New York City, whatever. And you will calculate the one from LA to Tokyo, and I'll just write the answers, okay? So for New York City, let's do this one together. So it did go down. So when you're doing the difference, it is now minus the past divided by the past. So the order of subtraction does matter. So it is declining. So 945 minus 1120, which will give us a negative number. And you're dividing by the past amount, which is 1120. All right, so let's do the subtraction. So 945 minus 1120. So that gives us $175 of the absolute change over 1120, which will be minus 15.6% as a relative change. Okay, so let's highlight it. This is the absolute and this is the relative. Okay, absolute and a relative. Now do the same for LA to Tokyo. So if you're watching this and you haven't computed it yourself, I suggest you pause the video until you see the solution. Okay, go ahead. Okay, now you see on the screen the answers. So the absolute difference is 350 and the relative difference is 25%. Looking at the choices, you can see that LA to Tokyo had the largest drop in the difference, the absolute sense, and it's the largest percent drop. Okay, they're both negative, but if you think of this as a drop, LA to Tokyo would have the largest drop both in the absolute and the relative sense. Okay? All right, question number 13. In 1980, 7% of children of age 6 to 11 were obese. In 2012, the percentage increased to 18%. What is the absolute change in percentage point and what the relative change in percentage points? So here you might get confused because you already have a percent. Ignore the fact that you have percent and just do the calculation. So the absolute change is just the difference between the two numbers. So you're taking 18 and you're subtracting 7. And the difference is 11%. I'm writing this in Word just so not to confuse us. What are we actually computing? All right, so this is the 11 percentage points. So that will eliminate those two choices. And now we need to calculate the relative change. So the relative change is you're going to take this 11%, or the difference, 11 percentage point. All right, 18 minus 7. And you're going to divide it by the original amount, the past amount. Not by 18, but by 7, because that's what we started with. And we get 11 divided by 7, which will give us something more than 100%. So 11 divided by 7. And you see, when I'm writing this, I'm already assuming that you understand when you want a percent, after you do get the ratio, multiply it by 100 to get your percent. And you get 157% as being the relative change, and therefore the answer choice right here is C. All right, so question 14 is a quick review on the mean, median, and the mode, just a computation. All right, just to review the concept. Now, mode here, are the numbers repeating? No, so there's no mode. The word distinct means specific, and there's no mode. And now we need the mean and the median. So the mean is the average. So we add all the numbers and we're dividing them by 5. So I'm going to go ahead and add these. All right, so it's 185 divided by 5. That gives us 37. So the average is 37 minutes, not 19. And then to get the median, we got to put them in order. So 15, 20, 35, 45, and 70. So the number in between is 35. So that statement is true. So statements 2 and 3 are true. So that's the answer, choice C. Okay. Another question on mean, median, and the mode. So we're giving, it says, a college wants to learn about how many hours students work outside of school. They asked 10 students how many hours they work in a week. The list is shown, and we ask to check which of the following is correct. It's basically the same kind of idea. So we'll look at the mode first. The number that repeats the most is not 10. The number that repeats the most looks like it's 15, correct? So this is false. The mode cannot be determined. Yes, we were able to determine it. So we left with basically, the two, the mean and the median. So let's do the mean. Let's add all the numbers and divide them by 1, 2, 3, 4. Oh, well, it does say 10. Okay, so the 10 numbers. Let's do that. I got 180 divided by 10. That gives me 18. So that means the mean is not 20. So the only thing, and it's not 15 either, so it gotta be 16 and a half. So we just gotta verify this, I guess. So we got 0, 5, then we got 10, we got 2 15s, we got 18, we got 20, we got 25, we got 28, and 44. So the numbers that are in between are going to be here, and we got to add them up and divide them by 2. So that will give us 16 and a half. So just to confirm that that's the answer. Alrighty, so nothing major here. You do notice that there is a presence of 0, so that can skew the data somewhat. Just, as a reminder, is that the mean is affected by extreme observations. The chart below shows the changing age demographics in the US. You saw this in the lesson, that particular chart. It's asking us to calculate the expected absolute change in the number of Americans over 65 years of age during this period. To answer this question correctly, you must also know that the US had a population of 319 in 2014 and 417 in 2060. So we asked to find the absolute change, and therefore we need to know how many people there were of that age in each time period. So in 2014, the population was of the people over 65 is 15% of 319 million. While it's projected to be 24% of 417 in 2060. So we're going to go ahead and do those calculations. So 15% of 319 gives us 47.85, while 24% of 417 gives us 100.08. And what is it asking us? Find the absolute change. It's okay to keep it in millions. We shouldn't write all of those zeros, okay? It's just everything measured in millions. So then you can go ahead and find the difference, just subtract them, and then choose the answer. So it's 100.08, take away 47.85. So that is 52.23 of a million. Million means 6 significant figures, 2 already here, so we need 4 more. So that gives us 52,230,000, which is choice B. You can also see it by just looking at the choices, but the concept is this, right? You calculate those percentages and then you're just asked to find the difference. All right, so Syracuse University is planning to convert some of the traditional classroom into art studios. It is recommended that each art studio have 28 square feet per student. By the way, this is not a density. This is a reciprocal of the density, but it's talking about the space per student to allow space for painting and blah, blah, blah. Each classroom they are planning to convert has the area of 725 square feet. So the question is, how many of those 28 square feet per student is going to fit in 725? So, it's 28 per student. The total is 725. So we're just going to go ahead and divide 725, which is the area, divided by the area per student. Area, and this is the area per student. All right, so if we divide that, we're going to get 725 divided by 28. That gives us 25.89 of a student. So we don't have enough space to fit 26, but we do have enough space to fit 25, correct? So the answer for 17, let me just double check. That's correct. So we got to round it down. So we can also have 25 students. Now, if we round it to 26, then it's just not going to fit that decimal part. If you multiply 26 times 28, it's going to give us, you see, if you chose an answer of 26 and you multiply it by 28, then you don't have enough space. Check this out. If you multiply those two, you got 728, which is 3 square feet short to fit that room. You understand? That's why you got to round it down. So that's a second example, just like with the representation question, where you have to round your answer down. So the result is going to be 25. All right, a company has 18 employees. Their average salary is $85,000. Their median salary is $52,000. Which of the following statements can be true regarding the salaries of the employees? Guys, remember, the average means you add all the numbers and you divide it by how many, while the median is you're arranging the numbers and you choose the one in the middle. We call this a true center. It's a number that separates the lower half with the upper half. That's exactly a 50-50% split. The median is a 50-50% split, while the average is not. So now, keeping that in mind, let's go through the choices. Choice A, all employees have a salary of about $85,000. What nonsense is that? That would not make a median 52, so no. Half of the employees earn a salary higher than 85. No, half is earning more than 52,000, and the other half is less than 52,000. So that's no good. All employees have a salary of about 52. Again, what is that about? Like, how could it be all? Then the average will not end up being 85. Most employees earn between 52 and 85. Why most? I mean, we know half earn more than 52, not most. And why does it stop at 85? Again, no justification for that. And that leaves us with the right answer, last answer, which is right answer, half of the employees earn a salary lower than 52,000. Exactly. About half. I should say about half, because the median is a true center of the data. Let's move on. Question 19 has to do with the investment. We have the prices for stock increases, and it's talking about where you're going to make more money investing in which stock. So the actual dollar figures that you see, the dollars, do not really matter. What matters is by what percent did each stock increase. By larger percent, or what we call a relative change, the stock will increase, the more likely you're going to make, well, not more likely, you will make more profit if you invest in a stock that increased by a higher relative change. Okay, so let's calculate the relative change again. All right, so we're going to do 2018 minus 2016 numbers over the 2016 numbers, like in terms of what you're going to be doing, right? So it's 114.28 minus 108.92, subtract first and then divided by the starting amount, and then get the percent. Don't forget to multiply by 100 and do the same for eBay. All right, so let's see what we get for Pepsi. It's 4.9%, okay? And we're going to do the same thing for the other one, for eBay, which I think is now owned by Google. I think so. All right, so let's see what we get here. All right, so it is 8.95 about percent. All right, so which one did better? The eBay did better. So looking at the choices, let's look at the last choice. The stock price of Pepsi increased by less in a relative sense, yes, compared to eBay, so it's less, which means that investor would have made greater profit investing in eBay. That's the choice, all right? Because eBay had a higher percentage increase, that means you're going to make more money investing in eBay in that period of time, even though, look at the numbers, eBay has lower stock prices. So it's not about the actual price, it's about the percent change. We did this in the lesson. Okay, let's look at the CPIU data. So the CPI measures the relative price of goods. The higher the CPIU, the more expensive, meaning that the things cost more in a given period of time. And the value of the CPIU give us the relative idea of how prices increase from year to year in terms of the buying power of the dollar. So it says, what was the approximate relative change in CPIU going from 1975 and then going to 1995? Again, just a little, approximation. It's asking for relative change. So it's 150 CPIU minus 50 CPIU divided by the older number, which is 50. So it's 100 divided by 50 gives us the 2 multiplied by 100, which gives us a change of 200%. Now that question number 21 is very important for us to understand. So 1975 and 1995, so the loaf of bread was $1 in 1975, and we want to know how much it would cost in 1995 based on the CPIU, because that's the index that tells us the relative pricing. So 1975, the index was 50, while 995 was, what is it called? 150, right? We did it just in the previous one. It's the same numbers. So then to get an answer, you can either use the information from the previous question and say, well, it's a 200% increase. So if something was $1, okay, and it increased by 200%, that would mean it's going to be a $2 increase. It's not becoming $2. It's going to increase by $2. So it's going to become actually $1 plus the increase. So that would be $3. So that's one way to answer the question. And the other way to answer the question is to look at the ratio. Listen very carefully. Look at the ratio. 50 goes to 150. By what ratio? Not subtraction, but the ratio of a larger number by a smaller number. If you take 150 and you divide it by 50, listen to this. This is extremely helpful and important. It means that the prices of everything on average tripled. That's what it means. You understand? If it goes from 50 to 150, that means everything tripled. Ratio tripled. So if that's tripled, it means price of bread is also going to triple, which will make the price of bread $3. I like to do this way. It avoids finding the relative change, but it allows us to quickly get, and it conceptually makes sense, right? It's tripled, so bread is also tripled. Gas tripled. It was $1 became $3. $1.50 became $4.50. Everything tripled in a period of time of 20 years. All right, here we go. Not 22. In 1990, the price of gold was $388. In 2012, the price of gold had increased to $1,790. By comparison, the CPIU numbers are given as well. And it's asking us to do these statements. We want to compare the percent increase between those two periods of time. So it asks us to calculate the percent increase. So let's organize it. So we got the year 1990 and we have a year 2012. Let's look at gold. So gold went from 388 to 1719, while the CPIU, which is index of goods, the prices of goods, went from 130.7 to 220.5. All right, so you can go ahead and calculate the relative change, or you can calculate the ratio. Both of those will give you an idea what it is. So if you like, you can on your own time go ahead and calculate the ratio. Calculate the rate, what we did before, now minus the past divided by the past, and compare the percentages. But I just want to do the ratios. So the ratio of larger number by a smaller number. So you're doing the ratio of 2012 number to 1990 number is going to be for each one. So for the CPIU, if you divide them to see how many times the price has increased, so 2020.5 divided by 130.7 tells us the prices increased by a factor of 1.687. By the way, that translates to 68.7% relative change. So if you do calculate the relative change, you're going to get this, which is also called inflation, that the price is inflated by 68.7%. While the gold, if you do the ratio of gold, the gold looks like it's more, isn't it? 1790 divided by 388 gives us the ratio of 4.6 times, which translate to a rate, you subtract 100% if you want to do percent change, it would be 360% relative change. Again, those numbers you can calculate on your own by subtracting and dividing by the past. Either way, the gold has a much higher increase in its price, 4.6 times, than the CPIU. And now looking at the answers, statement 1 is true. The price of gold was greater than the CPI, and then gold became cheaper. That's not true. So yeah, only one is correct. So that gives us the choice D. Question 23, the CPIU again for the year 2005 and 2013 is given. The cost of gallon of milk was $3.75 in the year 2005. Use the relative change in the CPIU to compute the expected price of milk. Again, you can do a relative change. I'm going to do a more quicker way where I'm just going to do the ratio. So the CPIU 230.2 divided by 195.3 gives me a ratio of 1.17 times. By the way, again, that translates to 17.9%. You see I'm removing the 1, That's how you go between the ratio and the relative change. But once again, I want to highlight this, that you just do the ratio, and then you take that ratio and then you multiply the price of milk on that. And notice I actually have that number on my calculator right now. So I'm just going to go ahead and multiply whatever I have on my calculator by 3.75, and it gives me $4.42, which is choice E. Okay, almost there. Let's go to question number 24. James received a gift of $1,500. He deposited this into a saving account, which was paying 0.7% interest at that time. Over the next year, the inflation rate averaged 2.1%. Now consider the following statement. So let's understand this. So he got $1,500, and instead of spending it right away, he invested it at the low rate at 0.7%. which will make his investment go up. But then over the next year, the inflation rate was making the buying power of his investment go down by 2.1%. Now consider the following statement. Let's see what happens. James' savings account has less than $1,500 in it by the end of 2017. Well, let's think about this. If he puts $1,500 into his account under whatever rate, his investment is going to go up because, you know, the interest is, he's going to earn money. We don't have to calculate what it is, but it's going to increase. So the fact that it's going to have less, it's not true. He's not going to have less money in that account. No, he's going to have more. It's not about the money. It's also about the power, buying power of that money. So that's why we got to look at the next statement. So in 2017, the buying power of James' gift decreased by about 1.4%. So what that means is basically, if this one is making his value of the money up by 7%, then inflation is going to put the value of the money down. It's not actually going to change the dollar amount. He's going to have more money, but the buying power of it is going to decline. 0.7 take away 2.1 equals to a decline of 1.4%. So that statement is actually true. But be careful, it doesn't mean that he's going to have less money in the account. It's just whatever money he will have cannot buy as much as 1,500 could buy, you know, in the prior year. And 3, James' gift earned around $10.50 in interest during 2017, but this amount did not keep up with the inflation. All right, so let's calculate. So 7%. All right, let's do math very carefully. So 0.7% of $1,500, that's how much he's going to earn, is going to be divide this by 100 to get the decimal. So it's going to be 0.007 times 1,500. Multiply that, and let's see what we get. So you get $10.50. Good. So that's true, but that $10 is not enough to cover the decline in the money because of the inflation. So that's why that statement is also true. So both statements 2 and 3 are correct. So that would be the answer for 24. All right. All right, let's go ahead to number 25. Consider the following table showing car ownership across 3 countries. In which country rate of car ownership is greatest? So you can calculate the percent or the rate of cars per person, and since it's talking about number of cars owned, so the one that has highest rate will have the most number of cars per person. So you just gotta divide all of these numbers, cars per people, this way, and notice they all have in thousands, so you can cross out those 1,000 to make the calculation a little faster. Okay, so for the first one, we're going to get what, 63 divided by 4,430. So that is going to be 0.014 and then we'll do the rest. You're going to see the numbers appear in a second. If you like to do it beforehand, pause this video. So here are the ratios. So the largest one happened to be the New Zealand. All right, 2 more questions. The median of the set of 24 quiz scores was 80. Based on this, which of the following is true? Well, again, because we're talking about the median, it has to do with half of the students scored more than 80 and the other half scored less than 80. So this will be that answer right here. It's about 50%. So once again, it's just this idea that the median represents the true center. It's being reinforced several times in this review. We also seen that in the lesson. All right, final question. The number of Facebook and Snapchat users in the first quarters of 2015 and 18 are below. All right, so both of them grew in millions, and we want to know which one grew faster, and it's including both the which one grew the fastest and which one grew the most. So as the other question, let's calculate the absolute and the relative change. The absolute change is just the difference, so you just subtract them. So 2196 minus 1441, that is 755. Divide this by the past amount. That gives us 52%. While the other one is 191 minus 80, that gives us 111, a smaller increase in terms of the number of users. But now once we divide it by 80 by the past, 111 divided by 80 and times 100 gives us 138.75%. Okay, so which one faster? The one that has higher percentage. Okay, which one is the most? That has to do with the absolute values. So looking at that statements, the first one, Snapchat grew faster, yes. Facebook grew faster, no. The relative change in total number of users was greater for Snapchat, that's true. The relative and absolute change was greater for Facebook, that's false. So that leaves us with the statement 1 and 3. So the answer choice A here. And on that, we're done. All right, I hope you found this helpful.